Welcome to Pinnacle Tutorials. To access our entire curriculum, join Pinnacle Tutorials and gain access to lecture videos such as this one, study resources, as well as revision content to help you excel in your studies and score good grades. In today's lesson, we are going to look at the foundations of business statistics. This is BS 242 Lesson 1, and honestly, it's one of the most important lessons in the whole course. Not because it's the hardest, but because everything else we do this semester is built on top of what you're about to learn today. So take your time with this one, don't rush it, and try by the end to understand exactly what statistics actually is, how statisticians think, and how to correctly classify any piece of data the moment you see it in an exam question. Let's start with a question I like to ask every new class, the definition of a word, and today's keyword is statistics. When you hear the word statistics, what comes to your mind? Maybe it's a football score. Maybe it's the exam pass rates. Maybe it's the price of millimil going up over the past few years. All of these are actually statistics in the everyday sense of the word. But in this course, we are going to treat statistics as something much more precise. We'll treat it as a discipline, a set of tools, a way of thinking that help business people make good decisions even when they don't have perfect information. And that last part is really the whole point of this subject. So hold on to it. By formal definition, we can say statistics is the art and science of collecting, analyzing, presenting, and interpreting data. Notice I said art and science, not just science. That is deliberate. The science part is the technical side of statistics. It's the one that encompasses things such as formulas, the table, the calculations, the things that have one correct answer. The part of art is the judgment side. The side where deciding what data to collect in the first place, deciding how to present it so people actually understand it, and deciding a set of numbers and what the set of numbers is really telling you about the real world. That is the art side. So, a good statistician isn't just someone who can compute a mean. It is someone who can look at a business problem and say, here's the data I need, here's how I'll collect it, and here's what it will be able to tell me once I have it. Now, why does this matter to you as a business student? We are not mathematicians or statisticians, so why are we learning this? Think about a real situation. Say you're running a small grocery and you're trying to decide whether to stock more airtime scratch cards or more fritters in the morning. You don't have perfect information about what every single customer wants. What do? What you're going to do is you're going to collect data. Maybe you track sales for 2 weeks. You analyze it by looking at the patterns, the averages, the peak times, what is being bought more and what is being bought less. And then you present it. And you can do this maybe with a simple table or a chart so you can see it clearly. And then you interpret it. You use what you found to make a decision about what to stock. That entire process from start to finish is statistics in action. It's not abstract. It's something you use in real business decisions for the rest of your career. I will need you to hold on to all the 5 verbs that have been used to describe what statistics actually does, because those are important. Now, since we know what statistics is, let's break it into the 2 major branches, because almost everything we will learn this semester will fall under one of these 2 headings, and exam questions love to test whether you can tell them apart. Okay, so the first branch is descriptive statistics. This is used to organize and summarize the important features of a data set, and we usually do that through tables, graphs, and numerical summaries like averages. The key word here is describe, okay? Descriptive statistics doesn't try to predict anything or generalize beyond the data you actually have in front of you. If I tell you the average mark of this class on the last test was 62%, okay? That's a descriptive statistic. I'm simply describing what already happened in the last specific data set, nothing more. The second branch is inferential statistics. And this is where things get more powerful and honestly more interesting. Inferential statistics is used to study a sample in order to make generalizations about a larger population. So instead of just describing the data you have, you are using it to make an educated conclusion about data you don't have. For example, if a market research company surveys 500 households in a town like Lusaka about their preferred mobile network, and then uses those results to estimate the preferences of the entire country, that's inference. They didn't ask everyone in Zambia, they asked a sample, and they are generalizing that sample and the data collected there to the population. That's the engine behind almost all serious business research, and we'll spend a good chunk of this course building it up. So, closely tied to these two branches of statistics that we've looked at is a distinction in the way we reason. And this tends to complicate a lot of people in exams, so we're going to take it slowly. So, okay, I think. So, some of the reasoning, we have two types of reasoning in statistics. We have what we call inductive reasoning, and we have what we call deductive reasoning. Unfortunately, I thought I had included a slide specifically dealing with this, but then I found that it was just a minor note on the other side. I thought I made a whole slide, so we will try to explain it in further detail though. So let's look at inductive reasoning. So inductive reasoning involves reasoning that moves from the specific to the general. In our language, that means moving from the sample up to the population, where you take a small piece of evidence and you reason upwards, outwards to a broader conclusion. This is the heart of inferential statistics. Think of it like this. If you test one spoon of mshima from a pot and it's well sorted, you think of it like this. You are going to conclude that the whole pot is well sorted. You went from one specific spoonful, your sample of the nshima, to a general conclusion about the entire pot, your population. And that's induction. Okay? And then we have deductive reasoning. So deductive reasoning works the opposite way. It moves from the general to the specific, from the population down to the sample. This is the type of reasoning we use primarily in probability. Here, you already know something about the whole picture, and you use that knowledge to reason about a single case. For example, if you know that a factory produces goods where 5% are defective, that's a known fact about the whole population of goods, okay? And if somebody asks you, what's the chance that this one item I just picked up is defective? You are reasoning deductively. You are moving from what you know about the general population down to a conclusion about one specific item. So here's a simple way to remember this for your exams. Inductive reasoning, sample up to population, that's inference. Deductive reasoning is the population down to the sample, and that's probability. If you can hold on to that one sentence, you get an easy mark whenever this comes up in any exam paper. Let us now look at the classification of data. So, this shows up almost in every single exam I've ever seen for this course, classifying data. Before you can choose the right statistical tool for a problem, you must firstly correctly identify what type of data you're dealing with. Get this wrong, and everything you calculate afterwards will be built on a shaky foundation. So let's build this up carefully, step by step. At the very top, data splits into two categories: qualitative data and quantitative data. Qualitative data, also called categorical data, is a descriptive data that uses labels or names rather than numbers. Think about things like eye color, gender, the brand of a car someone drives, or the type of a store a customer visited. A supermarket versus a tuck shop versus an online store are all different types of qualitative data. Notice that even if we sometimes assign a number to these categories for coding purposes, like using 1 for male and 2 for female in a spreadsheet, that number doesn't represent a quantity, it's just a label. You can't average a person's gender code and get a meaningful result. And that's the taste I want you to apply. If adding, subtracting, or averaging the numbers gives you nonsense, you are looking at qualitative data. Then we have quantitative data. So, for quantitative data, on the other hand, it's numerical data that tells you how much or how many. This is data where the numbers genuinely mean something mathematically, and quantitative data itself it splits further into two types, and this is where sometimes we tend to lose marks. So let's pay close attention to what it splits into. The first one is discrete data. Okay, so discrete data takes only exact countable values that you obtain it by counting. So, for example, a family size is a perfect example of discrete data. You can have 3 children or 4 children, but you cannot have 3.5 children. Please tell me who has 3.5 children. Even a 1 day old child in a family is counted as one whole child. Okay? So the number of cars a household owns can also work in the same way. 1 car, 2 cars, never 1.25 cars. That doesn't even make sense. So anytime you can imagine yourself literally counting on your fingers to get the value, and the value only makes sense as a whole number, you are dealing with discrete data. Now we have continuous data. So for continuous data, this is data that can take any value within a given range, and you obtain it by measurement, not counting. Height is a classic example of continuous data. A person isn't just 165 centimeters or 166 centimeters tall. They could be 165.3 or 165.37 or any value in between, limited only by how precise your measuring instrument is. So, weight works are the same way. My gym people, okay? You know, the weight works in the same way, and then even the time also works in the same way. So if you're using a ruler, a scale, a stopwatch, or any measuring instrument to get your number, and that number could theoretically have decimal places, you're dealing with continuous data. Let me give you more ways to lock this in, because I want this to be automatic for you by the exam day. Ask yourself 2 questions whenever you're given a variable. The first question is it a number at all, or is it a label? If it's a label, stop there. It's qualitative data. If it's a genuine number, move to the second question. Did you get this number by counting or by measuring? If you counted, it's discrete. If you measured it, it's continuous. 2 questions and you classify any variable correctly every single time. So, let's now put this into practice, because reading a rule is one thing, but applying it under exam pressure is another. I'm going to give you 4 variables that have actually come up in past paper sessional questions, and I want you to pause the recording after each one, decide the classification for yourself, and then we'll listen for the explanation. Let's go through them one at a time. So the first one is annual income of a household. And this one is quantitative continuous. Income is measured in kwacha and ingwe, and even though we often round it off to whole numbers, in principle, income can fall anywhere along a continuous scale. Someone can earn exactly 15,423 kwacha, 50 ngwe in a year. It's measured, not counted, so it's continuous. Then we have the number of visits to a shopping center. This one is quantitative, discrete. So this one is quantitative discrete because we are counting the visits. So a customer visited the shopping center 3 times last month or 5 times, never 3.5 times. Who goes to the mall 3.5 times? Nobody. So whenever the word number of appears in a variable description, that's usually your signal that you are counting, and counting means discrete. Then the type of store visited. This is qualitative. Whether someone visited a supermarket, a boutique, or a hardware store, we are dealing with labels and categories, not numbers that carry mathematical meaning. And we have the weight of a passenger. So this one is quantitative and continuous for exactly the same reason as income. Weight is obtained through measurement on a scale, and it can take any value within a range, including decimals. Okay? So that's how we do that. Now, since you've understood the logic and not memorized the examples, which is exactly what we want, let's move on. If you missed any one or two of the things that we have discussed here, you can just go back, apply the 2-question test that I gave you a moment ago. Is it a number or a label? If it's a number, was it counted or measured? And you'll get there. These 4 questions are almost guaranteed marks in section year of your exam. So this 5 minutes of practice today is genuinely some of the high value time you'll spend all semester. Let's recap what we've covered today, because repetition is how we actually let things stick. Okay? So, statistics is the art and science of collecting, analyzing, presenting, and interpreting data. We use it in business to make informed decisions under uncertainty. It splits into 2 branches: descriptive statistics, which summarizes what we already have, and inferential statistics, which uses a sample to draw conclusions about a wider population. That connects directly to 2 types of reasoning: inductive, from sample to population, which powers inference, and deductive, from population to sample, which powers probability. And finally, we learn to classify any variable as qualitative or quantitative, and if it's quantitative, as either discrete, from counting, or continuous, from measurement. Everything else in this course, the frequency tables, the mean, the median, probability, distributions, hypothesis testing, regression, all of it sits on top of the foundation we just built together. So if any of today's ideas feel a little shaky, go back and listen to this section again before you move forward. It's worth the extra 10 minutes now, because it will save you hours of confusion later in the semester. In our next lesson, we move into descriptive statistics, where we'll learn how to construct frequency tables and calculate the mean, the mode for grouped data. And these are practically guaranteed marks in section A of your exam, so I don't want you to miss it as well. Well, thank you so much for staying with me through this lesson. I will see you in the next one. Bye.